Okay, thank you very much for that, for the introduction. I hope you can hear me correctly.
Yes, we do.
Okay, perfect. And I hope that you can see my screen now. Okay, so the topic of my talk today will be around VIMS. Okay, VIMS is a platform that we at Capgemini Engineering are developing for IoT related tasks. Okay. The VIMS platform at its core is a digital twin platform, okay, that can be used for industrial IoT applications. Okay, so what we want to do is be able to use data.
Joseba, sorry.
Yep.
Sorry to interrupt, but we see your email, not the proper display, I guess.
You're seeing my email?
Yes.
Sorry for that. That is not my email. I guess that is someone else's. You're saying?
Or maybe you should start sharing your screen.
Can you see it now?
Yes, we do.
Okay, so you see the main slide, right?
We do. Perfect.
Okay, perfect. Sorry for that. So again, the core of the VIMS system is an industrial IoT platform, okay, where we have implemented a data-driven digital twin. I will come back into this concept a little bit later, of a factory or production line, okay, so whatever related to manufacturing, okay. What we want to have is a place that can gather information from very different data sources, particularly the shop floor, and concentrate all the knowledge that we have about how the process is doing, how the systems are performing, and allowing us to query that system and to use that information in a useful way via a mobile app or maybe via a desktop application or web application, but also allowing us to go a little bit further and being able to exploit that information in virtual reality and in augmented reality applications. Okay, so if we talk a bit about what VIMS is, okay, VIMS is a project led by Capgemini Engineering, which is funded by the European Commission under the H2020 program. Okay, so in this program, what we have is a consortium led by Capgemini Engineering, where we have some major industrial partners, okay, who will be providing use cases for showcasing and for verifying that the platform, that the VIMS platform is a viable platform that can be used in production scenarios. Okay, so we are implementing the VIMS platform and customizing it for real use cases in the premises of in the production premises of these companies. Okay, and making sure that VIMS works correctly for them. Okay, so if we look a little bit about how it all started, okay, first of all, VIMS is an industrial IoT platform which is hosted on the web. Okay, so and this here is a summary of the very first task that we took when I started working on VIMS. We had to choose one platform provider, okay, one platform as a service provider. We started with a list of over 40 different providers. Okay, from those 40, we made the first filter, and we chose those 7 platforms that you see there. Okay, and those 7 platforms were analyzed based on the criteria that you can see in the part below. Okay, so those are the key criteria that we identified as being the most important for being able to successfully create VIMS. Okay, we settled on Microsoft Azure. Okay, and that happened to be a very fortunate choice, because at that time, and we did not know that at the time, Microsoft was finishing the second version for the release of the Digital Twins, Azure Digital Twins platform. Okay, which worked and works wonderfully for the purpose of our project. Okay, So what you are seeing here is a very simplified version of what the architecture of VIMS looks like. Okay, what we have depicted here from left to right is the way, the flow of information from the shop floor on the very left. Okay, and maybe some ERP systems or SAP systems flowing through the platform and its different components, okay, into until they arrive at the business applications. Okay, the business applications are the actual applications that the people who have to do the manufacturing tasks, the people who will be consuming all this information will be using. Okay, and we have envisioned quite a few different business applications here. We will go into that in a minute. Okay, so just to highlight some of the most important components of VIMS, on the left, we have the edge part. Okay, the edge part allows us to securely monitor, register, and control edge devices. If needed, it allows us to perform advanced analytics on the edge based on the data that we have from the sensors. Okay. This information is collected from the different sources. So we have a direct connection to sensors, but we also have some factory data. We can connect to Osses of Pi kind of historians. We get all that data in the edge, and we can transmit that data to the cloud. We know that we are doing this securely and reliably. Okay, once we have it in the cloud, what we do is separate the data in flows. Okay, so in different paths. So we know that some data, we just want to store it. Okay, we want to apply some very quick analytics and store it. And that is what we have called the warm path here. Okay. But one other very, very important path for us is what you see here that we have labeled the twin path. Okay, the twin path leads us to the digital twin, to the Azure digital twins. In the Azure digital twins platform, what we have is a representation of whatever process we are monitoring, and this means all the parts of it that we want to see. So we have a combination of magnitudes which represent data coming from sensors. So this can be just the mass or the volume of a certain piece of equipment, but this can also represent process statuses. So are things going well? Are some alarms on or not? But we can also, when combined with the cloud-based analytics, provide KPIs. Okay, so we have a single place that we can modify, that we can query, that we can update, and we can use, and it's a combination of all the knowledge that we have about the current status of the system that we are monitoring. Okay. This data, of course, if needed, is analyzed, as I said, and this is a feedback loop. Okay, so we use information from the digital twin and from the databases to compute all the parts of the digital twin. Okay, and this information we store for historical purposes. So if needed, if we need to query the status of the digital twin in the past, we have some historical databases that we can use for that. Okay. Once we have the information in a useful manner stored in the databases in the cloud, we use that information through backends. Okay, so we have a variety of backends, and the actual configuration of those backends depends on the use case. Okay, so those are specific to the use case, to the business application that we are developing, and to the use case that we want to fulfill. And those backends expose all the information in a secure manner, so we can connect to industrial authentication systems and to company authentication systems, and we can expose all the information that we know about the different processes to these business applications. Okay, so these business applications for VIMS, we are centering around manufacturing and maintenance. So we have the ability to perform virtual training based on data that we have live or that we have experienced in the past. Okay, so we can go to a past situation and make sure that we can perform training based on that. And also we have maintenance solutions for predictive calibration, or maybe for just inspecting production lines. Okay, just being able to have all the information about the process in a single place. Okay, so for us, the elements that I want to highlight are three. The main one being the digital twin. Okay, and I'll come back into that in a second. The second one being the power of the edge. Okay, what we are doing on the edge. And the third one being the cloud-based analytics. Okay. So if we go to a digital twin, if you ask different people, you will get answers on what different answers on what a digital twin is. For us, a digital twin is a data-driven digital twin. Okay, so we want to have a graph in the sense of a directed graph. Okay, so where each node has its own properties and allows us and connection to the rest of the nodes in the graph, okay, and allows us to query properties, to update their values, to change relationships, so we can move parts of the tree from one place to another, and where we have a live representation of what the system that we are monitoring is. So for us, this is a data-driven digital twin, and this is the core of our experience, okay, of our digital platform. When we talk about edge-based computing, in VIMS, we have different use cases, okay? What one expects when talking about the edge in a manufacturing use case is to be able to increase visibility into the status of what the manufacturing processes are doing. Okay, so we have the ability to perform analytics on the edge. We can derive KPIs. We can know a lot more about what is happening without having to process data on the cloud. Okay, so we also want to be using this visibility. We want to be able to improve the maintenance activities and be able to perform better root cause analysis. Of course, one very important part is that in scenarios when we have very high requirements for bandwidth, or maybe very low requirements for latency, okay, and in our case we have both, we want to try to drive costs down by doing as much of the heavy lifting as possible in the edge, okay? In fact, one of our use cases would not be even possible without the edge, and I'll come back into that in a second. Okay. As a medium-term goal, we want to prove that it's possible to replace some verification tasks, some quality assurance tasks with real-time status monitoring. Okay. So what we are seeing in VIMS, and this is actually data that we are getting from our platform, is that we get a 95% bandwidth reduction, okay, and over a 90% latency reduction. So this is when taking into account the round trip of information from the edge into the cloud and back. Okay, if that information is processed locally, we are seeing a 90% latency reduction. Okay, and in some particular use case that we are targeting, we are seeing a 2% increase in the throughput of the manufacturing process. Okay. So what are we using the edge for in VIMS? For one of the use cases, what we have is a process which is depicted the time-based, the timeline of the process is depicted here. What we have is a drilling process, okay, which takes around 5 seconds. And after the drilling process happens, we do a measurement. As of today, there's a measurement that takes around 4 seconds. Okay, we in VIMS are replacing that process via machine learning inference. Okay, so we look at the system and we look at the incoming audio signals, and by using a device called the Neuromorphic auditory sensor, which is kind of a digital cochlea. Okay, this device sends spikes in different channels when it gets information from the different activations, okay, and sends that, and we collect that into what we call a cochleogram. Okay, this cochleogram is a very high dimensionality artifact. Okay, and what we do first is via the use of compressed sensing, reduce the dimensionality of this cochleogram. Okay, this feature is extracted after the dimensionality reduction. We feed that into a 1D convolutional neural network, okay, which performs and which gives us an estimate, okay, a very accurate estimate of what the drilling process is. Okay, and via doing this, you can have a very good estimate of the actual drilling, and we are aiming to reduce the OT to actually remove in the future this actual measurement with the machine. Okay, I've left a couple of references there, and we can discuss those later. Okay, another task we are doing on the edge, on the cloud, is how we can use the cloud, advanced analytics in the cloud, to be able to monitor the status of systems. Okay, in our use case, what we want to do is to be able to determine the calibration status of some sensors, okay, which measure temperature, pressure, and humidity, and assess that in real time by simply analyzing their measurements. So we want to see the data they are producing and say if the sensors are calibrated or not. Okay, we can do that because all the sensors are measuring a correlated magnitude, which is the ambient, and the ambient is generated by a single HVAC system. Okay, and we want to go from a periodic maintenance strategy to a condition-based maintenance strategy. Okay. The main output of this is that we want to be able to detect the calibrations in these sensors hours or maybe days after they occur, instead or as opposed to detecting them weeks or maybe months after they occur, which is what we have today. Okay. Also, we want the system to provide an estimate of how much time it has left until the sensors are completely out of calibration. Okay. So how is it possible to detect these decalibrations? What we have is again a system which monitors the output from the sensors. And again, it's important to note that these sensors are providing measurements for magnitudes which are deeply correlated into each other, because they are generated, the ambient conditions are generated by a single system. Okay, and it monitors these systems. It creates it implements a decoder. Okay, so what we have is a system which is guessing what each sensor should be providing, what reading each sensor should be providing. Okay, and comparing that to the actual reading from the sensor. Okay, what we see when we do this is that we are able to detect the calibrations for 100% of the studied sensors. Okay, some of them we need a little bit more of room. Okay, but for most of them, we can detect the decalibrations even before we arrive to the calibration threshold of the sensor. So we know a sensor is decalibrated even before its measurement is outside the calibration threshold defined by the company. Okay, which is actually very low. It's around the 4% for humidity sensors, less than 1 degree for temperature, and less than 1 Pascal for pressure. Okay. Another advantage of this is that the system can be continuously retrained with new data. So if the conditions change, we can retrain the systems to adapt to these new conditions. Okay, and the typical delay we are seeing for detecting these decalibrations of these abnormal behaviors is somewhat around days. Okay, it depends. Some sensors are easy to detect, and some are a bit more difficult. Okay, for this we have left a reference. We have published the paper, which is in preprint right now, which describes the whole process. Okay.
Perfect. Thanks a lot to all the speakers again. They were very